It is Thursday, November 3rd, 2016, and welcome to this episode of Code Evolution. So today I wanted to do a quick podcast about some of the lessons that I've learned with strict null checks. And, kind of out of the gate, for anybody that's decided or thought about using them, I can tell you it's extremely powerful and it's highly recommended. If you haven't really played with typed languages before and you kind of switch on the strict null checks, it's going to be a little bit sticky and maybe a bit frustrating, but you'll see the benefit as the more and more that you apply some of these constraints that strict null checks allows you to do. Now, going forward, what I wanted to show you was here is I'm messing around with typescript-dotnet because I want to upgrade it to be more refined in its constraints and take a deeper level advantage of strict null checks and how they're used. Now, initially, the way that I had this interface here called selector that is essentially a function signature. And originally it looked, just kind of zoom in and give you some better room here. It originally looked like this, right? And there wasn't this notion of this at all. And this worked perfectly fine. In fact, the interesting part about this is that although this doesn't necessarily directly apply to strict null checks, it was the usage and understanding of strict null checks that led me to realize that there's basically a flaw here, and it's a very interesting one, because it's very common for, when you look into using for each in a lot of arrays and things like that, what you find out is that this is very common. You get the value and then you get the index, right? And in some weird cases, it's even more complex and people have weird signatures, but specifically here, you would expect to get the value from what you were selecting, and then you would get the index of where that existed. But the problem is that's not always the case. You won't always get that, even though you might expect to always get it, and that's a problem. So I've been really diving deep in here, and this is the major lesson learned here. By turning on strict null checks, I've really kind of unraveled, I've kind of opened Pandora's box. In a way that I think is really, really beneficial. Because the first thing is that I need to be able to allow the consumer, the user of the API, to understand, hey, you can pass me this method, but either I'm going to be able to use it or not. For example, if they pass me a selector that doesn't have an index, or you have a selector that you don't require an index, then you're always going to be safe. But what if you pass me a selector that expects an index? Then you have a problem, because what if the method that is using a selector as a parameter doesn't actually pass you an index? Then you're getting this undefined value that you didn't expect. Now, I'm hoping people can kind of wrap their head around that a little bit, because it took me a while to really get my head around it. But it's really, really important to understand this. So we're going to go ahead and I'm going to walk you through these changes. I'm making these changes right now, and you can kind of observe as I make these changes and try to fix the problem of what I'm encountering. And one of the issues that I'm encountering, and I've logged an issue, I'm kind of created this dialogue of an issue, and I apologize to Dave Kavanaugh for the insane, back and forth. But he's been really helpful at trying to get me to figure out what the hell is going on here. And how to fix the problem, because I'm having some interesting type inference issues that I didn't have when I simply used an optional parameter. So at first I was frustrated because I thought, why don't I just have these two signatures or these two signatures underneath selector? The problem is that it could be one or the other, and there's no way to really discern which one for sure. So I realized that I had to basically break them into two. And so now this is the right way to do this. And I'm slowly but surely really realizing that I need to have one that's just a basic selector, which doesn't take an index, and then I need to have a selector with an index. The same thing goes for action and action with index in this case, right? And there's also predicate and predicate with index. And in the other cases, for example, these comparison and equality comparison, they're fine because this actually does equate to a true or false value, even if you have undefined, and the default is, strangely I think is true, but so that might be a problem. But yeah, you're allowed to not pass a value, and that's fine, and it's okay. But these are specific. You're expecting a number, and that's where it gets crazy. If you are telling the user, you should feel comfortable about putting a number here as this your parameter and go. But if you put it as an optional parameter, well, then, what happens when you don't pass one? Then you break someone else's code, which is not good. So moving forward, I'm diving in here, and here's an example of one, for example. So I'll back up here, and I'll show you what I had originally. So before, I just simply had this contains function as an example that took a compare selector as an optional parameter. And in order to, and this works completely fine, but the problem is that, if I was to follow the pattern that I'm talking about, with this kind of notion of optional selector, well, what if the selector was either the selector or it was something else, or it was also or it was a selector that could take an index? In this particular case, contains is completely safe because the code in the internal code doesn't require an index. It doesn't care about an index at all. It's kind of like, meh, I don't care. So this one is safe. So I've been walking through my code here. Let's go here and trying to find, so for example, like average was an interesting one. Average used to be just one line that was the selector as an optional parameter, and that could equal this special handler, right? Well, okay, that's great, but what you find out is that the lack of specificity ends up being a problem. So in this case, the selector does get past an index. So you want at least how I call it, and I may be saying this wrong, the root signature, which is this last line in a list of signatures, is the one that the internal code of your function assumes is the right one. So in a lot of cases, people will put, if they have a long list of signatures, they'll just put any in here, right? But because this is the last and default one, then this is the one that the internal code expects. The ones above it, on the other hand, are the ones that the consumer has available to them. So in this case, what I'm suggesting is that you can pass nothing, you can pass a selector, or you can pass a selector with an index, and all will be well, regardless. Now you could say, well, why are you not just going, or selector, right? T comma number. This also works, but what I keep finding is that, again, the lack of specificity is a problem, because what happens is this is considered effectively a single type. It could be one or the other as a single type. What I'm actually saying is, no, it needs to be one or the other for sure. It can't be this combo of the two, and that seems to be solving some problems. So we're going to keep going here. And let's move on to, I worked on this one, choose. Choose was another interesting one. So choose, if you dive deep into this protected method that actually choose is, the nice thing about it is in the protected method, you don't need all these extra overloads. Or extra signatures, depending on how you want to talk about it. You just need the actual selector with index that the internal code expects. The internal code is saying, I'm going to pass you a thing, and I'm going to pass you the index of that thing. And so you don't need to do any magic. So now if we go back to choose, for example, then all you have to do is make sure that your root signature matches that. Might be asking, well, why is any in here? This is just a nuanced thing. It's because the function's identity needs to match this this thing here, and that's all it is. But note that the actual externalized signatures are simply these three: empty, a t results matched selector, and another t results matched selector with index. And so again, we're gonna keep going. Another choose here. There's choose this one, there's choose this one. Okay, I could probably rerun this search here. Let me go ahead and rerun this. And okay, now we've gotten into let's see, distinct until changed is another one. Sorry, I don't want to dive into this enumerable thing yet. I want to just keep going down. To joined string, interesting. Okay, so let's see if we go to joined string here. This one is interesting because, again, if you look at the code, it's passing toJoin string here to the super, and toJoin string internally only takes, okay, and then select, okay, keep going, we have to keep digging, we have to find where the root of everything is, and what do you know, the selector actually passes an index. So I have to make sure that my select method here is proper. So again, I'll make the modification. I'll say, okay, this is the externalized selector. All I really need to do is create another one that says, yeah, I need you. These two are the externalized ones, and these are the internalized. This is the internalized signature. Now, I don't want to bore the crap out of you guys kind of going over this over and over and over, because that's what I will be doing here in a minute, is I'll just be going through all of these and trying to like unravel this mystery, this puzzle, which is, what I think in the end, what people are going to gain from this is, again, a much, much better type constraint and type signatures. So, for example, it's just going to be less mistakes overall and less errors overall in people's code. So again, this is just kind of one of the major, the long path led me to here when it comes to the lessons learned with these different strict null check stuff. Now, what you're going to see too is that pretty much one thing you're going to want to do, one of the lessons learned, is anywhere, if you decide that you want to do strict null checks, anywhere that you use an optional parameter, you really, really want to ask that question. Do I want to really be introducing an undefined value into my code? Which that's what an optional parameter does if you are putting the question mark, right? It's kind of just saying, yep, optional parameter, blah, 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 you now are officially could be undefined. And that's something that you want to probably avoid. So let's say, for example, you have a function a, and a can be blank. It can be something you can say function can take x number. And so in this particular case, what you have to understand is that this works just as well as function b x number. If you can imagine the difference here, there is no undefined possibility in this block, right? It's either nothing or a number. It's not nothing or undefined. And that's just the reality of, oh, that's right. Sorry, I apologize. I'm not doing this right. What I'm supposed to do is these are the external signatures. So I need to basically say that, right, okay, this is the right way to do it. So the above equivalent, let's identify the issue here. So internally speaking, here and here, these are identical. So what this is actually saying is that externally, as far as the user is concerned, you can pass it nothing, or you can pass it a number. But because these are the only two external signatures, and this is the internal signature, it's not allowing you to pass undefined. And we'll see this here. So we'll say A. We can do A8 to B8. And then what's interesting is I can do B undefined, and it'll be just fine. But I should not be able to do A undefined. Aha! There we go. So see the difference here. There's a significantly important difference in the way that A is implemented versus B. B and A functionally and internally have the same signature and could do the same thing. But externally, with this one, we're being more constrained, and we're saying, no, undefined is not an option in this particular signature structure. So I think I'm going to leave it at that. If you guys have any questions, please feel free to leave a comment, and I'll get back to you. But this is I think one of the biggest deals is understanding if you're writing code and you're trying to write good code for other people, setting up your API so that it is correct and that you're basically externalizing your intention in a way and saying, yeah, if you pass me undefined, it's not going to be good. Or in this case, you could say, you can pass me undefined all you want. I don't care, right? You have to make that decision. Some people are going to be on one side of that fence, and other people are going to be on the other side of the fence. And, again, leave your comments about, you might be that person like, I like silent fail, right? I am not the type of person that likes to silently fail, but I look for opportunities where it makes sense. And so I try to find this balance of silently fail when it's appropriate, but I side on the other side of things, which is to try to be more constrictive and prevent, one, preventing it by using signatures like this, and two, throwing if there's an actual problem. So thanks again, and if you like this video and it helped you, please give it a like. Otherwise, if you want to see more content like this, just subscribe, and we'll see you next time.